Good afternoon. Thank you all for coming to the post-flight press conference for Flight 61A in Spacelab D-1. To tell us about the flight and the gathering of scientific data during that entire period is the flight crew headed up by Hank Hartsfield. Hank, why don't you proceed with your video and your slides.
Okay, first let me say that very pleased you came out to listen to us. I think we've got a story to tell you. Before we get into the film, I'd like to introduce to you to the best Spacelab crew that's ever flown. And I'm really proud of it. It's my pilot, Steve Nagel, who headed up the orbiter side of the operations from the blue team, and Jim Buckley, mission specialist, who headed up the red team for the orbiter. Bonnie Dunbar, mission specialist, one of the payload crew with the blue team, and Guy Bluford with the red team. And then Ernst Messerschmidt from Germany on the red team, Reinhard Futter from Germany on the blue team, and Wubo Akkels from the Netherlands, who sort of floated between the two teams. We kind of called him Purple, but but they were an exceptional crew. I've never seen 5 people work in the Spacelab as hard as they did. We planned 12-hour days in the lab. I think in actuality they came closer to being 15-hour days, but the results speak for themselves. So without further ado, I think what we'd like to do now is show you a little film that we rushed together to give you the highlights of the flight, show you a few slides, and then we'd entertain any questions you may have.
Okay, I'll pick it up at this point. There was no doubt at the time of launch we were ready to fly. However, there was one question in our minds the last few days before the launch, and that was the weather, because Hurricane Juan was turning around in the Gulf, going one way and then another, and never actually threatened the launch. However, we were under the influence of that hurricane, and some spiral bands of weather had passed by the Cape. I guess the night before launch, we had some thunderstorms around Florida, which is usually a good omen for good weather the next day. And sure enough, the next day when we got out there, it was perfectly clear when we climbed in the vehicle, and I think there were just a few scattered clouds inland a little ways by the time we launched. We launched right on time, 12 o'clock, straight up. And as shuttle launches go, it was, I guess, kind of a ho-hum launch. Everything was nominal and worked just as it should. For anybody who rides through it, I don't think it's very ho-hum. Even a nominal launch is pretty exciting, but the important thing is that everything worked quite well. All the systems worked very well and put us into the orbit that we desired to go into. The roll maneuver off the launch pad's considerably larger on one of these missions, because instead of flying due east from the Cape, we had northeast up the coast, so it was probably to a spectator on the ground it looked impressive. It was a 135-degree roll. First stage was a normal first stage, duration of which was 2 minutes until the solid rockets burned out, at which time that they were kicked off. Here's a good scene of solid rocket booster separation. And for the next 6.5 minutes, we monitored systems, and everything, as I said before, worked fine. I'm not sure what it looks like out the window. I took a couple of peeks, but all the rest of the time my eyes were on the gauges all the way through ascent, and never saw anything anomalous at all. The post-insertion timeline went very well, got the payload bay doors open, and we were on or ahead of the timeline. And then 2 hours into the mission, we were into Spacelab activation, which Bonnie will talk about.
We started right on time with activation. Steve and I got the lab powered up. We got down to the door, the hatch, about 3:15, 3:30. Once I got into the tunnel, it was just like training. Very familiar. The inner hatch, tunnel hatch, opened very easily, buckled down. Getting into the lab was just like going into the trainer. In fact, I was amazed at how familiar everything seemed. And we started right down the timeline. Also, being a little bit of an ambitious flight, not only did we start the rest of the activation there, which we had another hour to do, but also started right into experiments. Wubo, Reinhardt, Ernst, and Guy all came in and started setting up. Towards the end of activation, then Ernst and Guy went to bed. The red shift started sleeping fairly early. I started with the comm and then worked the way around for the avionics air loops and the rest of the subsystems. Reinhardt helped start setting up some of the sled and the central venous pressure, which he'll talk about later. and Bubo started setting up the flight data file. I was particularly impressed with the tunnel, and you'll get to see a few more views about this, but very easy to translate down. It was an interesting area to experiment with in terms of the vestibular system, and very much like a silo. We had a little bit of fun in there. I'm going to take you down the tunnel right now. It's a little bit dark. We have a couple lights off. This goes down, it's translating down the long portion of the tunnel towards the mid-deck. We hit the tunnel adapter rotating here. You can see some of our garbage that we stowed here. It was a cool area. We found a good place to stow it, and it was out of the way. Coming through the tunnel hatch into the tunnel adapter and into the airlock, which was not only the area where we stowed our clothing from launch and landing, but where Bubo slept most of the time. Nice dark area. And we come into a lightly or a darkly lit mid-deck area. You can see the teleprinter light up there and around the stairs. I'm going to come up and say a few words to the flight deck crew who've been busy taking many Earth Ops photos. You'll get a chance to look at those a little later. Usually had this view as I came up. Surprise, I'm here. And can I visit and take a few moments to look out the window, which the flight deck readily agreed to. And you see Steve in the background there. Lots of cameras around. I think we're all very pleased with the support we got in the Earth observations area, and the flight deck crew will talk about that again.
One of the things we did early on was deploy a small satellite called Glomar, and you see the lid opening up here. We opened the lid up shortly before sunset, and that worked just fine. Then at sunset we maneuvered to our deployment attitude. We did that in darkness so that we didn't get sun into the bay, which was a constraint on NavX and on the lab. Shortly after we got into the proper attitude, we did our little deployment, which will work just fine. One thing that was really beautiful was to watch those sunsets every 90 minutes. And here you see the little Glomar satellite going up. Kind of cute. But we deployed that retrograde, so eventually it wound up in a little bit lower orbit than what we were in. Our prime objective on orbit obviously was to support the Spacelab. One of our secondary goals was to take what we hope to be very good Earth observation pictures. This gave you a good idea of what the view was from the cockpit. Here we saw the Atlas Mountains in Africa and Morocco. Looking down, we're looking right onto the continent of Africa. So you can see that we had more than just one window to look out. This particular attitude was a TDRS pointing attitude, which gave us a nice view forward. It also gave us a very nice view down into the bay using the aft windows. The layout of the cockpit was pretty much the same throughout the mission for us. We deployed our cameras strategically throughout the deck, very close to the windows. Normally there would be one person monitoring systems, another person looking on our Spock, which gave us our position over the Earth, and then one taking pictures, or the one that was using Spock would also be taking pictures. We use a 16 millimeter to take these shots of western United States. This gives a nice view of essentially what we saw, the curvature of the Earth, about the same movement that you saw on that photo. When we were in a gravity gradient mode, we used the overhead windows primarily. When we were in a ZLV attitude, we used the forward windows to get a panoramic view, and then used the overhead windows, which were looking straight down, to take some very detailed Earth shots. This is another view of the western United States. Here you see Salt Lake. To the south of it is Lake Provo, and you're just starting to see the western part of the mountains in central, west central United States. Again, you can see that we're moving at about 4 miles a minute, so we really cover an awful lot of terrain in a very short period of time.
Okay, this is unfortunately for the payload specialists as well as the mission specialists. We have to do our work in the space lab, which means that we have to head back down the tunnel, and this is our trip back down the tunnel, going back into Spacelab. One of the primary experiments that we did during our mission is to work the sled, and you can see in this shot Reinhardt sitting on the vestibular sled. We had two teams that were working on the sled. Ernst and myself on the red team did vestibular science work for the MIT people, and Reinhardt and Wubo did riding on the sled for the German people. And in this scene you can see one of us, I'm not too sure who that is, riding the sled in the y-axis. Surprisingly enough, I thought the ride on the sled in space was a lot easier than the ride on the sled on the ground. That looks rather provocative from the spectator's point of view, but it proved to be very benign from the rider's point of view.
Everybody thought this was the largest crew ever flown, but always three at least of us were hiding or disappeared in the lab. And we actually started our experiments right in the mid-deck during the launch. Between ohms 1 and 2, we measured central venous pressure. Due to the fluid shift phenomena, the venous pressure should be changed, and we tried to figure this out during the whole mission. We continuously measured this. Here in this picture, you see that the inner eye pressure has been measured on Ernst by Guy. This is a handheld tonometer where you expose or put some pressure on the eyeball and you measure optically what this pressure reading is. At the moment you see an experiment called hop and drop where the spinal reflex is being measured when a human is released here from a handle and pulled down by bungees, or on Earth being pulled down by gravity. The landing is prepared milliseconds, 50, 60 milliseconds before touchdown, and the muscles are activated, and this activation is triggered by the vestibular system, and this can be checked out here. You see Ernst hopping, being pulled down by bungees, which more or less replace the Earth's gravity to some extent, even if the acceleration profile is different. Ernst is here standing in front of the rotating dome, that is with colored dot marked dome, and the illusion he gets by looking into it is being floating around the axis, and you see what his sensations are by just looking in the eye and seeing a rotatory nystagmus in motion of the eye. Here is a simple, nice experiment, free-floating. Wubo asked me where up and where down is, and I try to point where up is, and he stops me someplace, and then he asks me, where is your up? And you see, in this moment, I just say I cannot tell anymore, because we prove with this experiment that there's no mechanism, no integrating mechanisms that can tell you as a subject what happened to you motion-wise.
One-third of the mission was devoted to life science, and one-third approximately we devoted for material science. We had 5 furnaces, we had process chambers, and whenever you deal with the materials in space, in the microgravity environment, you talk primarily about the liquid state of material. That's why basically we did some kind of basic science with the so-called fluid physics module, which was part of the material science double rack. And here you see the filling of a chamber that had some kind of concentration of a given liquid, and due to a concentration difference, you see some kind of motion of convection going on. This is the so-called Marangoni convection driven by concentration differences. By some other experiments, we proved that, for example, here also in a free column, we proved that there are immiscible liquids, and they behave in some way as described by theory, and that very much depends on the temperature. That's why we always changed in this device the temperature difference and looked at these phenomena and took scenic pictures as well as live TV. Like here, for example, a free column of silicon oil. To see the motions inside, we put a tracer in, and by looking at the tracers, you see the motion, and this again is Marangoni convection, which was one of the major themes of our flight. More than 30 experiments in
not only in fluid physics, but also in the furnaces and growing crystals were devoted to Marangoni convection, to this kind of phenomenon. Here, some other typical activity everybody of us had to do quite often during the flight. That was taking out the used samples and putting in new samples for our furnaces. As I said, we had all kinds of different devices. Some of them had constant temperature everywhere. We also had gradient heating devices. Sometimes the samples were heated with mirrors. For example, gold surface plated mirror. Here you see one of the samples, a silicon crystal in the middle of the shiny part. That is the liquid zone. And by moving the furnace, we move also the liquid zone through the crystal, hoping that we, after the end of the process, get a very clean, very homogeneous crystal back to Earth. This is one of the other facilities that caused a little bit troubles at the beginning of the mission, but we did some kind of IFM that worked out successfully.
Okay, we're back here to biology, about the other third, and this was the first flight which showed such a systematic large biology research. Here we feed the flies, which got a new tray of nutrition each day, and already there we found an absolutely new phenomenon, that is that flies in space do not know where to put their eggs. They don't put their eggs on the feeding tray all the time, and actually the eggs which are not put there have already shown to be abnormal and relatively different from the ground. Many results, very previous results we have from this research we did on different cells and bacteria, and it's extremely interesting to see what will come out there. At the mid-deck, we also used some of our liquids, in this case orange juice, to show some other effects on what zero gravity can do to us. As a nuclear physicist, I'm always interested in seeing liquid drops being excited with different modes of vibrations. And Reinhard had a little tool here to do that, with some air which would puff out these little openings on the sides, puff out with different frequencies, and you sometimes see that the droplet really moves and sometimes gets even into a square shape. If you just watch carefully, here, now you see it. It's really impressive, zero gravity. Floating is something which you fall in love with very quickly. Actually, it gets very difficult if you come back to get used to this sticky earth which pulls you down all the time. Here you see what you can do. You can very gently try to move a big blob of liquid around and try to get it in different modes of oscillation. The only thing you have to make sure is that it's not that big that eventually, if you need to do it, you can still swallow it. He was our master who taught us how to do it, because he flew before. One other aspect of gravity or zero gravity I wanted to show is 500 years ago we were all challenged by Columbus to put an egg on its tip without letting it falling over. And here is the boiled egg, and here I show how you can do that. Also, it reminded a little bit to the fact that Europe has called its participation program in the space station by the name of Columbus, so it was appropriate to show that egg. Little roots of garden grass you see here, and one of the funny things where we were very concerned whether these seeds will really grow and the roots will really grow the way they do on Earth. And one thing you see is that seeds did come out, or the roots did come out, but they all came out in different directions, also because they did not sense gravity. And this experiment was one of those very successful ones. Here we see corn seeds having grown, and this was an experiment where we wanted to investigate the hormone transportation in the roots, which basically would give the information of where down is. And we have shown the preliminary result shows that the plants did behave exactly the same way in space as on the ground. Here we have still a general view of the laboratory, which after a few days starts to look like a real Earth laboratory. That is to say, procedures and papers and things hang all over, which was very nice during the working period, but for some of us, actually the red crew had to clean up later on. It probably was pretty much a lot of work to get everything squared away.
This is a shot of Bonnie coming back from the lab to the middeck. Even though we spent 12 hours or 15 hours in Spacelab, we had to come back and partake, so to speak, of the food in the middeck. And so this is a shot of the blue team getting ready to fix a meal. You can see Hank is taking some of the food containers out of the pantry, or out of the galley, which worked extremely well throughout the whole mission. And the team is putting the food on the food tray. And in this scene, you can see the three of the crew members have lodged themselves down in various positions in the middeck with their individual food trays, eating the meals. And you'll find that eating in space is very similar to eating on Earth. You use a knife, fork, and spoon, and we ate out of refrigerator kind of dishes, as shown in that last scene.
We ran a few experiments of our own on the middeck. One of the pairs of binoculars we carried are very high-powered gyro-stabilized, and with the gyro cage with the motor turning, you can see some effects of gyroscopic precession. Also on the middeck to the right of or left of that scene, rather, you'll see the treadmill, which we did use for cardiovascular conditioning. I've always had a thing about Jim having bigger arms than I have, and I thought I'd set out to correct that on this mission, but it didn't work. The middeck is our living area, sleeping area, the whole 9 yards, and it would get pretty congested at handover times, although at other times like this, there's a fair amount of room down there when people were back working in the lab.
When you operate on Earth in normal spring, then the spring force has to be at least that great, that large, that it can carry its own weight. If you go in zero G, then you can adjust both qualities in a way that the motion, the propagation of waves along a spring happens very, very slowly. So we carried a few springs with us and did some experiments. It looks as if we would have had a lot of time, but I have to tell you that most of these demonstration experiments have been done the last night, where we rushed through, and sure, we took a few pictures, but you see, I managed finally to get some of these fundamental oscillation in springs, and this is something when you really study them, gives you a nice insight, because you cannot do this on Earth.
Well, we didn't have that much leisure time. Only a few spots in time where I really operated the ham radio. That was a good way to find out where you are. You always could listen to strange voices from all over the world. And but we had an automatic device that also recorded all these voices and calls. Sometimes I got the impression that they were heating up the shuttle, so many airwaves or radio waves came up to the shuttle.
These shots are the shots taken on the last day of the mission, and you can see the blue team is up trying to get the ship ready, and the red team, Ernst and myself, are back in the lab closing it out for the last time. We ended up shutting down all the experiments and putting stuff away, and the last day was really quite a busy day trying to get the lab in order before shutting it down and proceeding home. And in these scenes here, you can see both Ernst and myself short of doing the last little item, shutting down the Spacelab.
Well, the closeout went remarkably fast and remarkably well. I was really pleased with it. We had an uneventful entry. Here we see the tracking cameras at Edwards picking us up in the turn around the head and alignment circle at somewhere around 40,000 feet. I took manual control of the spacecraft at just under Mach 0.9 after the Mach buffet. The bird handles real well. It flies just as nicely as Discovery and Columbia did. I was well pleased with the handling qualities. Here I'm about to roll out on final. We're up, I guess, about 10,000 feet at this point. Got right on the desired glide slope and brought it in towards the landing. Steve did his job for us and got the wheels down. That's always a very important part of the mission. But the weather was just as forecast. It was a beautiful day. It was